that this part of the program can be very interactive and that people have questions to ask. We have mic runners who will be able to hand them out. I also pre-populated a few questions to get us going. But first, let me introduce everybody. So Brett Singer is a senior scientist and head of the Sustainable Energy and Environmental Systems Department in the Energy Technology area of Lawrence Berkeley National Lab. He earned a bachelor's in mechanical engineering from Temple University and his graduate degrees from the University of California in Berkeley. In 2016, Brett was inducted into the Academy of Fellows of the International Society of Indoor Air Quality and Climate. Dr. Singer leads research on physical chemical processes that mediate transport and fate, and controls that affect air pollution exposure in indoor environments. Major themes of his work are strategies to achieve synergistic improvements in indoor environmental quality while designing or retrofitting buildings to mitigate climate impacts, and the ways that human behavior also influence these ideas. He's guiding professional motivation to provide unbiased science to inform energy and environmental policy. So welcome, Brett. Nice to have you here today. Bob Kiss is the Executive Vice President of Technological Operations at Upside Food, which creates delicious cultivated meat grown directly from animal cells. Previous to Upside Foods, Bob had approximately 3 decades of industrial biotechnical experience where he helped develop and manufacture multiple biotherapeutics for treatment of breast cancer and lymphoma, amongst others. He had an illustrious career at Genentech, where he helped design the manufacturing facility just down the road in Vacaville, and his team was integral in getting the plant up and running. Bob was also the vice president at Zutro Biopharma, a company that's working to commercialize new technology for biotherapeutics. Bob has published extensively in the scientific literature and been a leader with respect to tech transfer in the engineering community. In 2019, Bob was elected to the National Academy of Engineering for contributions to mammalian cell culture and microbial processes that produce recombinant proteins and antibodies. I'm very proud to say that Bob holds a bachelor's degree in chemical engineering from UC Davis, and he has his PhD from my alma mater, MIT. And we're delighted to welcome Bob and learn how he's using his expertise in biotherapeutics and protein synthesis to help feed our growing population in a humane and environmentally sustainable way. Next, we have Cristina Davis, who's our Associate Vice Chancellor of Research for UC Davis and a professor in the Department of Mechanical and Aerospace Engineering. She previously served in my role as the Associate Dean of Research for the College of Engineering and rolled out the strategic research vision that we've been seeing and led extensive grassroots efforts amongst all our faculty to develop it. Her main scientific interests are in chemical and biological sensing applications and use of technology to speed biomarker discovery, including novel biomen's disease and bioinformatics. She leads several multidisciplinary research teams in the areas of chemical sensing, and she has a research portfolio that has a very diverse and broad array of agencies that fund her work, like the National Science Foundation, Department of Defense, National Institute of Health. She has considerable experience dealing with intellectual property, including patents and copyright of software. She's the inventor on 13 issued patents, with many more pending, and has played an instrumental role in the development of 3 startups over her career. She holds a bachelor's degree from Duke University and a PhD from the University of Virginia. She's a fellow of the National Academy of Inventors, a fellow of the American Association for the Advancement of Science, a fellow of the American Institute for Medical and Biomedical Engineering. And she's received numerous awards, such as the Department of Air Force Commander's Public Service Award, the UC Davis Distinguished Scholarly Service Award, and the UC Davis Chancellor's Innovation Award. Welcome, Cristina. And finally, it's my pleasure to welcome Tony Meyers, who's the Chief Operating Officer of the California State Water Project at the Department of Water Resources. The State Water Project is responsible for delivering water to 27 million Californians, more than 2/3 of our state's population. It's the largest state-owned water facility in the US and one of the largest in the world. In addition, the State Water Project is providing hydroelectric power to the state as well. Tony oversees a team of 2,400 people at the State Water Project and has the Herculean task of climate-proofing California's water. Tony has had a long and eventful career in engineering, including work on some of the Department of Water Resources' most ambitious and significant infrastructure projects, including the reconstruction of the Oroville Dam spillway, which was a massive multi-year project involving thousands of engineers and construction workers. And he pulled that off with an impeccable safety record. Tony holds a bachelor's degree from Cal State University, Sacramento, and is a registered civil engineer in California. He's held numerous positions in his 15 years of service at the Department of Water Resources. Prior to state service, Tony worked 29 years in the private sector as a consulting engineer. Welcome, Tony. So you can see we have a really exciting panel representing so many different stakeholders as we try and map out these tensions and solutions. So I did prepare a couple of brief questions to get us going, and I asked each one of them to briefly, in a sentence or two, describe the biggest challenge they're grappling with at the moment. Very easy task to do in 1 or 2 sentences. And if it involves competing objectives, what are the tensions? So we'll start with Brett.
Thank you. It's a pleasure to be here. That's a hard question, even though you told me in advance. I would say that we've had this great opportunity recently to expand our studies of indoor air quality to more disadvantaged communities, low-income households, where there are the greatest challenges. But understanding the challenges that they have is also a challenge itself, because they're facing so many other challenges in those households getting through around in life. So figuring out how we can be part of the solution and helpful without allowing our methodologies and our pursuit of knowledge to negatively impact people as we try to understand their challenges.
Thank you.
I can use one word: cost. Now I'll expound on that a little bit. When I was in the pharmaceutical industry, the fraction of total cost contributed by manufacturing was quite small in relative terms to the total cost of developing and commercializing products. In this effort to produce cultivated meat as a source of food, it's all about cost. It's all about manufacturing cost.
Risa, thank you for setting the stage with the question to challenge us. I think for me, in the Office of Research, one of the things that I've had the privilege of stepping into is that our campus has a lot of really excellent research already going on. In fact, the last couple of years, we hit a point where we had $1 billion of extramural research that was happening across the whole campus. That's kind of stunning. But I think we can do more. And I think that we have an opportunity to actually build teams that are even more diverse, that have community partnerships, and that we can tackle some of these big, giant challenges that I think several were highlighted here today. And that almost all that is happening at the boundaries between a lot of different disciplines. So we're trying to think of how do we foster more of those teams. So.
And I'd like to build upon what Bob said with regards to cost on delivering affordable and clean water to the state of California. We deliver water to over 70% of the state's residences. Of that, there's also 750 acres of irrigated farmland, and affordability is really critical for the ability for those farmers to continue to be sustainable in a market where food prices usually stay fairly flat, except for the last couple of years, and we have to be really cognizant of the fact that their needs are different than the M&I needs of the 27 million that we supply water to. Of that 27 million, over 8 million of those are disadvantaged community residences, so affordability is really critical. And as we continue to manage the State Water Project, which has fueled the state's economy for the past 60 years, providing more than $400 billion annually to the state's economy, creating 8.7 million full-time jobs and 160,000 farm worker jobs. It's just at absolutely critical that we manage, and this is our intention, manage the sustainability and resiliency of being able to deliver that water in our now hotter and drier climate reality. It is really a big factor on how we're doing it, because over the next 20 years, we're going to see about a 12% decrease in our water supply, and by 2070, it's going to be more like about 24%. And so that's why we're constantly creating new ways to make sure that we can continue to deliver that water.
Thank you. I'll keep asking you a couple questions and then open up to the floor. Brett, your research has provided the scientific basis to inform energy and environmental policy. Can you give us an example?
Sure. We actually have done a lot of research working with the California Energy Commission, which in the state is responsible for the building energy efficiency standards. And in a great visionary stroke, they've incorporated indoor environmental quality as a key feature of building performance, right? Buildings are not energy-using devices. They're for people to be productive and live happy and healthy. So we've done quite a lot of research to help with creating ventilation standards, for example, for new homes that are built airtight, for commercial buildings, et cetera, so that we can have good air quality and also meet our climate and emissions goals.
Thank you. Bob, the world's population is growing and climate is shifting. Cultivated meat seems to address challenges in multiple dimensions. What challenges are there to scaling up cultivating meat and getting into restaurants and on consumer shelves?
So we heard earlier in the very nice talk about concrete. There'll be more than 10 billion people by 2050 on the planet, and as affluence increases, more and more of those people want to eat meat as a primary source of food. We cannot, as a society, produce those quantities of meat by conventional means without significantly impacting the environment of the planet. But to replace a sizable portion of that conventional meat with cultivated meat will require massive scale of production. There are three main elements of developing processes that can be cost effective so that this could be a viable means of producing food. One of them is the source of raw materials, the cost of raw materials. Today those materials are made for the pharmaceutical industry to make biological products using cell culture. It's the same basic technology, but the cost of those materials is far too high to be used in this application. So we talk about tensions. That supply chain does not exist to support doing what this industry is trying to do. So that supply chain needs to be created. And suppliers need to want to be part of it and provide those materials, but in a much different business model than they provide them today to the pharmaceutical industry, for example. So raw material costs, capital costs, massive scale of production to grow cells as a food source requires production equipment that prevents microbial contamination of those processes. You're growing living cells. Bacteria grow very well. Animal cells grow very slowly. It's a technical problem. It can be solved, but today the cost of the systems to do that is very expensive. Those are essentially sterile processes to protect that product. So the cost of equipment needs to be reduced to enable cost-effective production at the scales that would be necessary. And third, the performance of the process needs to be improved. This is a new technology. The cell lines used to make these types of products did not exist 10 years ago. They've all been developed. And so they're not mature. So the yields of the processes are currently low. Those need to be significantly increased. So those are the three technical factors that must change significantly to enable this to be scaled up and become a viable source of sustainable food production, which is the goal.
Thank you. Cristina, you have such an interdisciplinary research portfolio, and you have a lot of success in the startup and IP space. So I was hoping you could tell us the biggest challenge you found in doing interdisciplinary interdisciplinary research and taking it to that level where there's IP.
Absolutely. Well, I have to say, I just love doing interdisciplinary research. I think that is where a lot of exciting work is happening. One of my longest term collaborators here on campus is in the medical school, and I've been working with Nick Kenyon there for 19 years, which is the whole time that I've been here. And I have to say, I was very lucky. I met him through looking up some faculty in the phone book, and he answered the phone. So first of all, getting somebody to answer the phone, and this is back when we had phone books, so that's also a pretty good story. It tells you a little age on that one. But getting people who are willing to take a step and who are willing to have that meeting that you don't really know it's going to go anywhere, but maybe it will. And then I think trying to figure out how to speak each other's language. That's a really big hurdle for sometimes. And so, getting people who are just willing to make a silly mistake and say, I don't really understand what you just said. Could we talk about that a little more? And just kind of having those kind of conversations. Really lucky to have had some great collaborators here on campus. And then I think also another step past that is when you get ready to start thinking about research projects. So as academics, we frequently think about publications. That's what we're raised on in grad school. We have that mindset. But not everybody in every discipline thinks about patents or copyrights. And so being able to explain to them, okay, this is what this process looks like, and then helping that team navigate the process at the campus level. Because, as the University of California, we have a process about how you apply for an invention, record of invention, disclosure to campus, and then you take those next steps. That can be a little daunting and also has a ton of vocabulary that's very foreign to a lot of folks. And so I found that just, taking your time and having those clear conversations and everybody just willing to learn really helped a lot.
Tony, the State Water Project has been around for decades, but the climate and weather patterns it was designed for are no longer holding. Can you tell us briefly about the Delta Conveyance Project, also known as the Delta Tunnel, and how it will transform resilience while keeping ecosystems sustained and not endangering species?
Yeah, that's a good question. That's one you can talk on for probably 2 hours. First thing, climate change. What we're going to see, or at least what's being predicted, is less snow in the mountains and greater runoff during the winters, more flashy storms, higher peaks in the stages of the rivers as they're running through during the winter. And most of the states' backbone water systems are developed with dams that would capture snowpack and then spring snowmelt and then deliver it during the summers with the conveyance systems, because you have spatial differences between the supply and the demand, and you also have the differences with regards to the locations of the people where the moisture occurs. So the development of newer technologies, newer infrastructure that better matches that is what Delta Conveyance is all about. Delta Conveyance Project is our best climate adaptation strategy that we have, and it's an absolutely great one because it's located in the North Delta, just south of Sacramento, near the town of Hood. And it incorporates two actually, intakes with state-of-the-art fish screens that are circular in nature. They're called T-screens. They were invented and they're manufactured right here in the Delta. And so there's a homegrown guy that builds these things, and they have a width of the size of a quarter, and they minimize the velocities that go through that, 2.2 feet per second, which allows fish to safely swim past them without getting sucked in or tied to the intake structure. The cylindrical nature of them increases the surface area, which allows those intake structures to be smaller in nature than they would be if they were just traditional. And we designed it so that the concept, maybe some of you have heard it, is a big goal. When we have a large flow in the river, a high stage in the river, there's excess water in the system, and we then pull the water off of the stage, basically scalp off the peak of the river, and then pull that into the tunnel. It runs 45.2 miles underground, 140 to 170 feet underground, to minimize the effects of the landscape and the land use patterns. Way different than 1982's peripheral canal, where you had canals that were going to divide lands and areas and properties and roads and communities. This is now all underground. There's only 2 launch shafts where all the construction activity will be, where the tunnel boring machines are now launched down, and then they talk on board. They're going to go in 2 directions. We've also relocated the alignment of the project to almost mirror I-5. It's not down through the middle of the delta, so it has minimal impacts on the delta communities. During construction, we put in parking rides and buses and transports in order to carry the workers, so that we have minimal cars through the delta. And there's a terminal pump station to pull the water out, and it delivers it directly up into the Bethany Reservoir, bypassing the existing South Delta pumps at Tracy at the Banks pumping plant. We still are going to use that as our primary system, because if it's not broke, we'll try to fix it. But it's the only knob we have to operate the state water project. And if you look at your homes and you're busy in your kitchen and your kitchen faucet goes out, you can still go use your bathroom faucet, and you get redundancy. State water project right now has no redundancy. If we have a plant that goes out, the whole system goes out. And so what this allows us is a redundant system. 2 knobs, mutually exclusive, to operate state water project, to be able to deliver water, continue delivering that water in a more resilient way that is not impacted by sea level rise, not impacted by climate change in any way. It allows us to pull water from a clean area up near the Sacramento town. It doesn't pull water down in the south where you got salinity intrusion, and you got to manage the CBP and all the different reservoirs to help keep that salinity intrusion out. And it's just a much better system that's going to give us the opportunity to mitigate for any delta earthquakes that might impact the system's ability to move water, and just provide us a much safer, cleaner, more resilient way to continue to be able to provide that water. And as I said previously, it'll give us the opportunity to continue to provide water at the same level we are right now, clear into 2070 and beyond.
Thank you. I'll open it up for the floor. I have a lot more questions, because I could have a conversation with any one of you for many, many hours. There's a question over there. There's another mic up here. You guys can find it, please.
Thanks, Rosa. And I want to follow up question for Tony Meyers. This about water and sustainability and farms in California you alluded to. So full disclosure, I'm actually a farmer too, but I'm going to speak against farmers' interests. So well over a decade ago, I was talking to a policy expert, and what she told me about California water was, 1, farms use a ton of it, percentage-wise. 2, that the federal government controls a lot of California water. And then 3, one of the big problems was that the feds had signed long-term contracts with very cheap water that didn't put the incentives for farmers to control the water. So you had silly things like California farmers planting rice as opposed to putting it in Louisiana or someplace. And then the right answers would be to do something like the Israelis, where you have drip irrigation systems, which puts on the farmers the requirement to invest. And the right answer is maybe you got a long period, 10, 15, 20 years, where you let the farmers know exactly how much the prices are going to rise, so that they would have the incentive to make those investments. So my questions to you, Tony, are first, is it in your mind farms are a big problem? We're not solving that problem of having sustainable water. 2, are the feds an important part of that issue that you have to deal with still? And 3, is this the right problem to focus on? And or is that the right, something like that, the right solution to the problem of having enough water? A lot of questions.
Debate there that we could really in depth. Before you take the mic, can you keep a listen just for a second? Could we go over that first question one more time? And then do it one at a time?
Sure. The first question is the farmers and the farm use of water one of the biggest issues that you have?
Farm use of water is a big issue. We are separate from the feds because the feds have the CDP project, which is Shasta as the major reservoir and also. And we work as partners. We are separate. We have separate systems. We do have combined systems from the Tracy plant south to San Luis. And so we work in partnership with them through that area. They own it, we operate it. And the farms that we provide water to, they realize that they have to be a greater steward of water if they're going to be able to continue to farm. Because with SIGMA, which is now enacted as part of the Department of Water Resources management arm, they can't take water out of the ground like they used to. It's now managed through the California Water Board. And we keep track of the sustainability plans that they filed, and then if there's any issues with those sustainability plans, we work with them, and then if they can't get into compliance, then they get reprimanded, and then there's going to be penalties from the California Water Board. So they really have to watch how they're going to start managing their water, because it's going to be incumbent on them to create a sustainable flow of water vertically, so that the groundwater doesn't create magnificent amounts of subsidence, which we're dealing with in our delivery of water through California Aqueduct down through stretches along I-5 because of the amount of groundwater that's been extracted. And when you take into account the droughts that we've had through the last decade, 2-3 year droughts that were very significant, and then you survey the monuments that we go through, you see during those years how much has subsided because of the amount of groundwater coming out. They're not going to be allowed to do that. So they're going to have to figure out a better way to farm, to manage the farming that they do. So I think that is going to make them more intelligent. We're also seeing some of the farmers that we work with putting more drip in so that they don't use as much on some of the orchards that they're growing, you know, pistachios and the almonds you see down on I-5. And I think it's going to work itself out because economics is going to be the key with one of the water farmers that we're working with. And I'll just go ahead and say it now because I think they've been doing a fabulous job of trying to get control over this. It's Dudley Ridge and the West Side Water Group, which is all west of the aqueduct. They have actually fallows in the ground because they can no longer continue to water as much as they used to. And so they pulled some out because of the need to be able to farm this intelligently.
The second part was.
Could we, I just want to make sure we have enough time for everybody to get in some questions in. And we will have time at the reception to probe further. So does anybody else in the audience have a question that they want to ask? There's one over there and in front as well.
Hi, thank you for the nice messages, nice panel discussion. So my question is like, in California, there are certain problem of the water crisis and as well as the drought. So but we utilize almost 3 to 4% for cooling the data centers in California. And yes, there are many technologies coming up like the cooling system and all, but still they are not enough to guarantee the resiliency of those kind of data centers. So is there any other technology or any other evolving things are coming around to guarantee the resiliency of the data centers as well as minimize the water crisis?
So the question is about data centers and water usage.
Yes.
Is that for me, I guess? Okay. I'm not too sure, and I don't have an answer for you with regards to data centers and their use. I know they're high users, but I do not know the effects of how to answer your question, but I can certainly get together with you after and be able to get a response back to you.
And we can also loop in Vinod, who was talking about the massive increase in energy that we'll have from data centers, so we've had some good conversations.
Yeah.
We have another question from our audience.
Yeah, we've heard a lot of really interesting talks about what might be called societal level challenges, tensions you call it, and really at the level of society, which is kind of a thing in terms of the scale is different from the past in a lot of cases. So we have representatives here from engineering research community, one industry, one government. Obviously, those three entities have to somehow articulate to actually be effective in addressing some of these challenges. So my question is, have the mechanisms of the past, where academics become entrepreneurs or industry lobbies government, politicians, or a number of other mechanisms, are they adequate to solve these scale of problems? Or do we need to think about new ways in which we can all influence each other?
That's a great question.
Just a small question.
Well, and I have to say, I think we're better at those interactions now than we were 20 or 30 years ago. But I think there's still room for us to grow. We do have more pathways for professors to work with industry as well as the national labs. So there's a lot more pathways than there used to be. I actually think I'd like to give a little credit to the state and federal governments, because as they are putting out some of the things that have been in the CHIPS and Science Act and other things, they're actually helping to prioritize some of those interactions. And whenever there's potential for resources to be able to push forward ideas, I think it incentivizes people to try to solve some of those problems. I'm hopeful that that's actually providing some motivation for folks. Anybody else?
Yeah, I can give you a really tangible example. We do a lot of work with the Building Technologies Office of the Department of Energy. And for a number of years now, they've been very focused on trying to understand what their role is and how they can use funding of research and development and demonstration projects to advance these societal goals, working with industry. So they're recognizing that the way for them to have the most impact, the way for the Department of Energy to have the most impact, is working in collaboration with industry and seeing where there are gaps. There are certain things that are going to be funded by the private sector because there's a good profit motive, and that's terrific. And then there are some others where maybe right now there isn't that, but the funding can help advance some technologies that could then, at some point later, be profitable and certainly would be have societal benefit.
I can make a plug for UC Davis. There is a consortium here, ICAMP, Integrative Center for Alternative Meat and Proteins. And so this is industry, academia, probably some governmental involvement as well, bringing the parties together on this topic. And it's a huge topic, as you alluded to, and we need more things like this, more organizations like this, bringing everybody together. These are huge problems. They can't be solved by folks not collaborating. We must collaborate, and we must tap into, in this case, the bioeconomy topic and the funding that will be there that we need to tap into to make this possible.
I'm going to add one item here too, if I could.
Oh, please, guys.
From State Water Project standpoint, DWR, we have a mandate from AB 1020, Assembly Bill 1020, that we have to carbon-free our energy sources to operate State Water Project by 2035. California's grid is mandated for 2045. So we have a 10-year acceleration that we have to apply on that, and we're working with academia, CEC, and others to figure out the best way to do that. There's a ton of solar. Is solar the right thing to continue? Because that's good until you get to about 5, 6 o'clock at night, but the peaks are always 6 to 9, 5 to 9, and that's when we have to maximize our hydropower. So that is one of the problems that we're looking at, so that we can make sure that we stay ahead of that, because it's a $3.2 to $3.5 billion cost that we're going to have to do in order to make that switch. We want to do it again as cheaply as possible.
So we have a question over there.
Quick two-part question for Bob. We've seen some plant-based and alternative meat options come around the market in the last couple of years that seem to be very popular and then seem to sort of lose favor. Do you see that as an advantage, that they sort of proved the concept and didn't deliver on the product, or do you see that as a challenge that you might get grouped in with them And then also, is a meat manufactured in a lab without a mother and father, is that vegan or is that not vegan?
So to the second question, it depends who you ask. So there certainly are vegans who would eat this type of product because they're vegan for specific reasons that would be addressed by making products in this way. Yeah, so the first part of the question in terms of some products like Beyond Meat, Impossible Meats, had a great acceleration in uptake of product, and then they've faltered, shall we say. They've had challenges, and sales have declined. So that's certainly on our minds as well. How do we avoid that type of an outcome? I don't have the answers to that. My focus is figuring out how to make the product. Others are obviously focused on that question, but it is a very valid question. So there's a lot of market research that gets done to try to understand what happened there. Why did the demand fall off, and what can we do differently with these types of products?
There's a question from Elsa.
I just have I just had a question. I was sitting here and thinking that National Academy is supposed to find the top engineers and give them the status and all that stuff. But in fact, when you're working on these great projects, which I think are fantastic, and we've had, I think, a very good meeting because we've heard all these ideas about how we need to move forward. But my goodness, I don't see how to do it without this huge groups of people working together, 50, 75, 100. How do you pick out the engineer that you think should go into the National Academy out of all of these? And maybe that we're going to turn into an academy of managers. If the person that rises to the top is going to be the manager of that project. And I don't really want to start a discussion here today. I just want to point out that how you identify the person who should really rise to the top and become the star on these kinds of projects, really, maybe we're measuring the wrong thing. That's all I'm going to say. I guess it wasn't a question.
Thank you, it's an excellent point. One of the other questions that you had prepared thankfully there's great questions on here, was where did the national labs fit into the whole research infrastructure? And I think that question, part of my answer was going to address that question or that comment that you just made, which is that among other things, we do team science, big science, right? As you point out, some challenges really need that. And it's really a gratifying place to work because people do put the mission, the public mission of the laboratories first. And yet we have quite a few members of the National Academy among the national labs. So I think the people who do exceptional work, even working within those team environments, still get recognized, even if they're not trying to forward their own careers or their own selves, that doing that work can be recognized.
To follow up on that, because another question in our prepared list that we had as a backup was about team science. And I think as we move forward, there will be more and more team science, and we have to think about how our reward structure changes as a part of that. But also, as you said, the selection pressure, on how do you pick out what those achievements are. At least at the university, one of the things that I have been really happy to see in the last 19 years that I've been here is the understanding that we don't just work alone, and that as we go through our merit promotion and tenure processes, that we actually get recognized for the team science, and that the person who did engineering work, maybe they're not the corresponding author on that paper, and that's okay. And there's other ways to identify that. So I think we just have to keep working on that, I think.
Eva has a question.
Thanks so much for this session. I came here from New York, attracted by the title of this symposium. I love it. And it's really been the focus of my work for the last, believe it or not, 50 years. And, you know, there are two things that I grew up being an urban planner, transportation systems planner, and computers and data, even go all the way back. I learned on an IBM 1130 with punch cards. And there are two things that my teachers taught me that have guided me all my career. One is that a chain is only as strong as its weakest link. And for me, that's turned out to be data. The definition of data, data objects and the application profile interfaces. And tensions at the edge depends on the transfer of data across interfaces. So I was wondering if maybe each of the panelists could scale on a scale of 1 to 10, how serious you found in your areas of research, how serious is the problem of a lack of data definitions and data interface definitions? In my field, urban planning, connected vehicles, autonomous vehicles, energy transmission charging infrastructure, the weak link is the data, lack of definitions. And I would give it a 9.9 out of 10 in seriousness. I was wondering if you could each, sort of one by one, scale your problem, scale the data problem in your specific field. Oh, and also I should say that there are multiple standard development organizations that are available that I've participated in for the last 40 years. And they have not come up with a body of definitions that helps urban systems turn into smart systems. I was just wondering in each of your fields what you were finding.
That's a terrifically good question. There's a lot of overlap, I think, in our fields, and that we're dealing with the built environment and the air quality of buildings, et cetera. And clearly there's an explosion of data, right? So data availability is mind-boggling now, okay? So many millions of people have indoor air quality monitors in their homes, some of which are providing accurate, useful data, many of which are not. So in addition to the problem, just to add to the problem you discussed, right, data definitions, but I think data quality is also a really big issue that goes along with that. That said, I do think that we have such great technologies for data and also for data management. I feel like we just haven't quite caught up with what we can do with the data collecting technologies that are available and the data that's coming in. And maybe AI will help with that. I mean, I know it's like the answer to everything, but I think that some of these things, the scale of managing it is difficult for individual humans to figure out, and you need sort of teams or collective intelligence to figure out how to both screen and then use that data.
Thank you for that. I realized I didn't mention the second thing that I grew up learning, and that is GIGO, garbage in, garbage out. And I fear that as technology gets faster and better, the garbage in gets promulgated faster and gets put out faster. So I'm not sure the answer is in the technology. I think the answer is actually in the interdisciplinary conversations and the nailing down of the standards so everybody understands. Can you imagine when the revolutionary founders of our country, we ended up with 13 different states. Can you imagine, instead of coming up with a single US dollar currency, we ended up with 13 different currencies. Each state got to develop their own currency. Then maybe we have to have a different conversion with Virginia, et cetera, et cetera. That's what I feel we're developing in all of our smart systems across all of our different fields. If we don't focus on defining the data, we get garbage in, garbage out. I'm curious, on a scale of 1 to 10 then, Brett, what would you say is the seriousness of the lack of data definitions in your field?
What was the number you had? 99 or something? I mean, it's a huge problem. But I don't think it's actually an unsolvable problem. And I think that recognizing, I feel like we are making progress in that realm. But it's not the data, the advances to generate or collect data are happening faster than our ability to do the standardization, essentially.
Thank you.
I would say it's certainly a big challenge. The one I like is data hath no predator, right? Because it can be generated so easily, but if you don't know what to do with it, it just becomes a different kind of a problem. So when you're dealing with biological systems, there's every type of omics has evolved some technology for generating data, but still not really understood how to work with that to make the most of it and learn from it. So it's a high score. We're a company of 200, and we have our own data sciences team to help deal with this type of challenge. So we're trying to understand fundamentally what's important biologically in what makes meat taste good, what makes this cultivated meat taste good or not taste good at the molecular level, so that we can learn from that and improve our processes. So it's a very important challenge.
Thank you.
Yeah, so my niche area that I'm working in is chemical and biological detection and metabolomics. So I'm part of that multi-omics revolution where there are not data standards right now. I think it's a Wild West. There's a lot of opportunity there, and I think maybe some of the data revolution that we see happening in other fields might help inform us. But right now, I don't see harm being caused yet. But we are not capitalizing on the successes of how the technology is operating and the types of discoveries we're making. Could be more, and they're a little bit more limited because we don't have that standardization and approach that you're talking about. So I think maybe like a 7 for us.
Thank you.
And I want to thank you for that question, because it couldn't be more appropriate for the time that we're facing, because we're a 65-year-old project. The water department's been around longer than that, but it's been fairly siloed organization up until the last few years. We've got no shortage of data, but it's not uniform across the departments. They've all got their own way of doing it. We have 13 currencies, if you will, and we're working at uniforming it, making it standard across the whole organization. Like I said, there's no shortage of data, but being able to manage it and retrieve it in a usable form, we need to know with our aging infrastructure and our maintenance management on all of our equipment, what we did a week ago, what we did a month ago, why that machine broke down, what are the tendencies, what is the past history, what's all the maintenance records on it, so we have a better understanding of how to fix it and be proactive, because we're dealing with equipment that's 55, 65 years old. And if you think about a classic car, because everything over 50 meets that mark, and a few of us here that do that as well. We are operating classic cars on a daily basis and running them at 100 miles an hour. And we have to depend on that every single day to move the water from the state of California. We're not rebuilding a classic car and towing it behind a camper and taking it to trade shows and to car shows. It's operable. It's a truck, and it's working every day. We have to understand the data behind each one of those pieces of equipment. And so that's one of the big hurdles that we're working on right now.
Thank you.
And from a score, yeah, it's 9 and up.
Thank you.
I know I have a lot more pressing questions, but I know our time is also precious. But I'm certainly very interested in how cultivated meat is challenging traditional agriculture in the United States. And I'm very interested in the silver tsunami of retirements that we're facing in infrastructure and electric power generation in this country. So I have lots of more questions that I could ask, but we are at 4:40, and I don't want to take too much time away from our poster session and mingling at the reception. So is there any last pressing question that someone would like to ask? And if not, then let's thank all of our panelists.